Hello and welcome. In front of me, I think you can see another camera here because I'm going to show you something else in this particular video, which I think is important in or may be useful to you when you're on holiday to learn how to do coding. Because in today's education, you can't just rely on the textbook information, the information that you receive from school, from the textbook. You need to expand your knowledge outside that which you learn in the textbook. In other words, you need to use the internet, for instance, in order to gain knowledge in certain fields. And one of these is to know how to do the coding. I know in school you do have coding clubs and so forth, so I come to reinforce that by introducing to you a small gadget that you could be able to acquire and be able to use it at home in order to continue the learning process. That's why I have this second camera, and you can see I have it mounted in such a way that it looks directly down on my dining table, so that I'm going to show you that one in a moment. And then I'll also go to my screen and be able to show you the IDE which comes with it, so that you can be able to understand what to do with that. So let me first of all show you the Arduino kit itself. So these are some of the components which come with the Arduino kit. And I want to start with the Arduino itself. This is the Arduino over here, this small circuit here, this board. This board is what we refer to as the Arduino. There are so many boards which are available. The basic one is called the Arduino Uno, and it is this one here. So it will come as the major component, because it is a circuit which will run all these components. It is a component where we are going to feed our sketch or the code into it so that it can perform certain functions. So that is the Arduino Uno itself. There is a cable which is going to power the Arduino Uno. There is this plug here which is connected to this socket on the Arduino Uno, and then the other side is a USB plug. We just need to push it into the USB socket of the computer. This cable does two things. One, it powers the board. It provides the necessary voltage of about 5 volts, and it is also through the same cable that we can be able to upload any code from the computer to the board. So let me put that one aside, the Arduino aside, so that I can talk about the breadboard. The breadboard is where now we are going to do all the connections. The function of the Arduino is for us to construct a circuit. Once we have constructed a circuit, we need to connect it over here. And it is so easy to do the connections because, like for example, this one is a light emitting diode. If we want to connect it to the board, we just push it into the holes that you can see there. So it automatically becomes connected. So the Arduino kit comes with so many components. I've not been able to put all of them here. Like for instance, when it comes to the LEDs, you would have about 5 red ones, 5 green ones, 8 yellow ones, and so forth. It comes with so many of them. These are light emitting diodes. It comes with capacitors. Again, I just have one of them here. It comes with capacitors of all sizes and of different makes. There are switches that come along with it. There are resistors, very many resistors, and there are potentiometers. There are these components here where we need to learn how numbers are formed. When you look at any digital displays, you'll see numbers which always start like this. So we'll be able to understand how they come about, the code that actually runs these numbers. We have relays, we have buttons for the switches, we have grids where you could be able to design so many other small circuits. This one is like a jockey for a computer game, or for, so you can see we can be able to learn a bit of codes which run such games where you use a jockey. And you can see that it got pins that we can be able to connect onto the Arduino Uno. Maybe one other thing that I should have mentioned is that the Arduino Uno has got several pins here where we can do direct connections. You can see this gadget has got those pins, so it's just a matter of pushing it into these holes or these ones, depending on the kind of circuit that we have constructed. So the Arduino also can be powered using dry cells. So this one takes the AA size of cells. I would recommend that you purchase the ones which can be recharged, so that all you need to do is just recharge them if they run out of power. Reason being, you might mount your Arduino on a project, and once you do that, you need to be powered, so it can no longer be connected to the computer. So you need to power it using this dry cell. How is it connected to the Arduino Uno? There is this plug here where you push it into the socket and it gets connected. So these are experiments that you could be able to do just on the dining table, for example, because you can see the connections are so neat. They are not like the connections we have in the lab, whereby it is usually messed up. The wires that we use for connections, they come as a bundle. You can see these are just wires. All I need to do is just get one of them and roll it out, and it gets attached from here, and then I can keep them away safely later on. So these are the wires that we get once we remove it from there. Again, how are the connections done? Very simple. Just get that sharp tip, you drive it into the breadboard, and it gets connected onto a wire below this plastic. The other one can go to a different part of the breadboard, or even to the Arduino Uno, because these ones will now be separate. The Arduino Uno can be there, the breadboard where we've done our connections can be there, and the wires can be able to link the Arduino Uno to this particular circuit. And you can see it's a very neat connection, unlike the connections which we experience in the lab. There are some of the things you could be able to do at home to learn the coding, because unlike the other methods of learning how to code, where you don't see that what that code does, this one actually runs physical gadgets. Like, for example, you might want to run one where you have a blinking LED. What is the type of code which makes this LED to blink? When you look at most electronic circuits, they will usually have indicator lamps. These indicator lamps are usually light emitting diodes, and you find that they behave in different ways. One could be blinking, or maybe when the gadget, for example, if the gadget is completely, charged, then you have a red light and it lights, or maybe a green light which lights continuously. If it is still charging, you might have a red light which is blinking. How do we get them to do that? So you see, we are trying to learn something which works in our daily life, and we want to know what is the kind of code which runs this gadget. So we are will be learning this from by looking at the code first of all, and then seeing what it does, and then we ask ourselves, what if we change this? What will happen? What if we change that number? What will happen? And that way we are able to learn coding in a much interesting way, instead of learning it the usual way, where sometimes it's just numbers and letters that you see, and it is not interesting at all. So this one enables us to see exactly what that circuit does. you've got motors, and you've got power sources for the motors. You've got others which can be able to measure temperature, and these boards are manufactured by different companies, so that they have put together what that particular board is supposed to do. So instead of building it all the way from scratch and connecting everything on the breadboard, they connect everything for us. They solder it properly at the back, because we don't have to rediscover the wheel. We can use some of the already tested components and finalized to build our project. So that does not prevent us from building our projects, because when we want a power supply for the motor, for example this one, we'll just need to connect it here, and then it can be used to run this motor here. There is another type of motor that we call a servo motor over here, and you can see this one is a step motor, this one is a servo motor. For those who are interested in robotics, in building robots and all that, a servo motor is very important, and even a step motor is important. How about this sound gadget? It can be able to detect, sound signals and so forth. How about this one? This one looks like a keyboard for feeding numbers into some kind of grid. So you could think about a grid like this one, or a grid like this one, and we are sort of like trying to control it using this. So it's I would say that the Arduino is one of the best components out there that can allow us to learn this by experimentation, when we experiment. And it also allows us to learn by doing things practically. Unlike situations whereby in class, most of the situations are done theoretically, over here we are able to learn coding by, first of all, seeing what an already existing code does, and then we tweak it a little bit, we change a few things within the code. It may run, it may refuse to learn, to work, but it provides us with an opportunity to keep on going until it does what we want. Like for instance, if I can be able to show you the code that runs a single blinking LED, you might want to design one which runs 2 of them or 3 of them in a pattern, so that it forms some beautiful pattern. What kind of code do I need to write here? What kind of code do I need to repeat? Because some of the things have already been done for us, and we don't have to rediscover the wheel. It makes learning of coding to be very interesting to you. So this is what it does. So in the next part, I'm going to show you now the IDE which we install in our computer in order to verify the code that we've written. First of all, it gives us an opportunity to write the code on that page and then verify the code. If the code is right, it allows us to upload it to the Arduino, and then once we upload it to the Arduino is now going to run that external circuit. So let's go there. So before we go to my desktop, so that I can be able to show you how the IDE does all this, once you get your Arduino kit, it doesn't come with these boxes. These boxes I have sort of designed. When you go to the supermarket, you'll be able to see boxes like this. They are called organization boxes, and they can help you to organize most of these components. Like for instance, now the LEDs, I'll be able to put them in this piece of paper, put them on one side. The Arduino, it can come and occupy this space here. So they are of different sizes. That box takes some of the components. There is another box here which is a little bit longer, and it is opened from the side, and you can see it's got other components that I didn't show you. I just showed you part of the resistors, part of these amplifiers here, and it's got a small boxes where you can safely keep all these components, and they don't have to be all over the table. So once you have used a component, you just need to return it in its specific place, and then you close the box. So I found it necessary to have about 4 boxes of the same. When you go to any supermarket, you'll be able to see these organization boxes. Just you can get a large one or a small one, depending on how many you might need, but I would prefer you get a large one with the divisions inside, so that you can be able to put all these small components together so that they don't get spoiled. Because if you have all these components all over the table, some of them are so tiny they will just get lost. Like for example, a component like this one, which is a thermistor. This one is another thermistor, but this one is big enough, but this other one can get lost, and you find that to get a component like that one to run a particular circuit may give you a lot of problems. So I would recommend that once you decide to get your Arduino Uno, also try to get an organization box where you can be able to store all your components away. If you can't get an organization box, I can be able to show you how you can construct yourself your own using just simple cardboards. Simple cardboards or PVC foam board. You can be able to construct a simple organization box. Maybe that is one of the projects I'll be able to show you over this holiday. So let's go over to my desktop so that I can show you the IDE where we write down the sketches and then upload them to the Arduino board. So this is it. Let me go to my Arduino board. I'm going to switch on the IDE, and where is the icon for the integrated development? It's here. Let me switch on the one that I was just using a moment ago, because I've got the latest version of it and the old version. I want to run the old version because I found it working properly with my Arduino Uno, and this is it. So it is opening. Let me maximize the screen, and you can see already the moment you open it, there is some code which is written there. The good thing with it is that you will be able to just follow the instructions. The instructions which are given with these double slash lines, okay, they are not part of the code. For example, wherever you have that slash line, you can read what it tells you, what the code will do. Like for example, the setup function runs once when you press reset or power the board. And then there is the code, void setup. There is these curly brackets here, some other curly brackets over here. With the time, you'll be able to understand what these curly brackets stand for. And then initialize the digital pin LED built in as an output pin. In the LED, in the Arduino board that you will acquire, and I will suggest that if you are beginning, you acquire the Arduino Uno. There is a switch here that you can always press. Can't be able to see it from there because now I'm using that camera and this one now is off. I'm not using that. So this is the switch that we are talking about. You press reset or power the board. To power the board means you get this cable. This cable has got a USB plug which you can push into one of the USB sockets in your computer. It's got the other side whereby you can put it into this other plug inside here. Once it's connected, you push this one to a USB plug socket, and that is what it means by powering the board. So the board is powered. Alternatively, I think when you were looking at the board, my box, I don't have it here, there is a cell holder for 4 small dry cells. So you can buy the dry cells which are rechargeable, so that you don't have to buy so many of them. Each and every time they run out, all you need to do is just recharge them, and you continue using your circuit. So the other piece of instruction here, initialize the digital pin LED built in as an output. So this is what you write. This is the code when you want the digital pin LED built in, that is the LED which is built into the board as an output pin. You say pin mode, then there is a bracket LED underscore built in. You know, you've given a name to your LED, and you've even given a name to the pin to which it is connected, and then you say output. Then there are those curly brackets. Like I said, when you start writing this code, you'll find that these brackets already exist. Yours is just to enter information there according to certain rules, depending on what you are designing. Some second slash lines, the loop function runs over and over again forever. I'm sure you may have seen situations whereby you have an LED which is blinking like that continuously. We have them in most electronic gadgets. So what controls these light emitting diodes are simple codes. So here is an opportunity to learn how those codes work. For example, over here we are told the digital write LED built in high. So the LED is going to switch on because it's connected to a high voltage. And of course the explanation is here. Turn the LED on. High is the voltage level. It's about 5 volts. But 5 volts cannot be connected directly to the light emitting diode. It will destroy it. It will burn it out. So what happens? We use resistors, and those resistors come in the kit. They're here. Unfortunately, I can't be able to use this camera to show you, but in this box there are other many components which come with the Arduino. So, and then it's going to wait for 1 second. 1 second is 1000 milliseconds. That is why there is that 1000. So in the beginning, you will just design your circuit. You don't even need to design the circuit. You just need to connect this board to your computer, and that built-in LED will start following this code. Then what you can do, you can get to your computer and change this number. For example, instead of it being 1000, you can make it to be 500. And then you test that code, whether it is correctly written, and then upload it onto the board. How do you do that? You do that using this cable. So this cable is used to power the Arduino, as well as upload any kind of sketch that you write there. Or in this Arduino environment, we call these codes, we call them sketches. We don't call it coding, although basically it is the same thing. It's just the same thing. So that's it. It's going to be off for 1 second again. That is 1000 milliseconds, and then on, and that runs forever. You can be able to change those timings in order to see how it behaves. If this one is something that is of interest to you, because it's something that you could be able to do neatly on the dining table, like I've already shown you that it doesn't occupy a lot of space. All you need to do is a laptop, your Arduino kit, and some comfortable space where you can do the connections. And then after that is just a matter of playing around with the various circuits that you have, so long as you follow simple rules. Like for example, every time you use an LED, make sure that there is a resistor in series with it of about 220 ohms. and those resistors are provided there. You'll find it comes with about 15 resistors for 220, about 10 resistors of 1K, about other 10 of about 10K. There are potentiometers there, and so forth. Like I just showed you, once you get your Arduino kit, you can get these compartments, these organization boxes. They're called organization boxes from any supermarket. They look like lunch boxes, but they are not strictly lunch boxes, because when you look at the inside, it is split into various small components. It's for keeping most of these very small components in a neat way, in a safe way, so that they are not all over the table. Because if you have them all over the table, it will not be different from the kind of situation which you use in the lab. And you are trying to avoid a situation where that situation which you use in the lab, you don't bring it to your dining table. You want your dining table to be as neat as possible, the connections to be very smooth, quick and neat. And you can be able to disconnect your circuit very, very quickly, very neatly, and then you store away your components. So if this one is something that you're interested in, you can buy the Arduino kit from eBay. Hopefully by the time you see this video, I'll have put a link in the video description where if you just click, it takes you directly to where you can be able to purchase it. Take time to look at the various boards that are provided there at eBay. I would suggest you get the basic board, which is the Arduino Uno, the first Arduino. Get it, and then use the thousands of codes which come in the library. For instance, if I go here where I have sketches, you can be able to see where I have a file, and then I go to open, or just look at the examples. You can see all these are already codes that have been written by volunteers. There's this one for the Ethernet. There's another one they are calling the bridge. There is another one they are calling the USB keyboard, and they give them different names and all that. And each and every time you click on one of them, like for instance, let's go to display and we go to the bar graph, and we see what kind of code we have. If I maximize that, you can see that there is already a code that exists. If you are able to connect this particular circuit on the breadboard, you can be able to slowly be able to see what it does. This one is like learning coding from the code itself. The code is already written, and then now you can see what it does. Then you work backwards to see how it was written in the first place, instead of doing it the standard way that we learn the code and then we upload, and once we upload, if there is a mistake, the circuit does not work, you may spend a long time there and the code doesn't work just because a simple thing is missing. Why don't you look at one which is already working and then try to study the code and ask yourself, what can happen if I change this number? What can happen if I change this one to this? What can happen if I remove a comma or a bracket? Or what is the meaning of this particular word? You are doing it by trial and error. And because you cannot spoil anything, you're just at home, the only thing that you need to be careful about is that with the very small gadgets, ensure that there is always a resistor in series with that. So in this channel, I'll be taking you through some of the steps that you can be able to follow when you are connecting your basic circuit. Like for example, we'll start with the blinking LED. Now that you are at home, you might want to know, what is this blinking LED? What does it do? So I'll show you the blinking LED. I show you the code which runs it, and then we can be able to to change a few things on the code or the sketch, have the IDE verify it. Once it is verified, then we upload it to the board, and then we see what it does. It's quite interesting. You can spend a whole day learning coding using the Arduino, and since it is so interesting, that's why I'm recommending that you get your kit and you do it when you're at home, because when you're at school, there will be certain challenges that will come. One, you may find it very difficult to get a computer to use with your kit in school. Again, the school program does not allow you to do something like that unless it is in a club, in which case maybe the clubs will take a long time before they acquire something like this. So that's why I'm suggesting, why don't you get a kit all by yourself, start designing some of these things, and then now you can apply that knowledge to come up with fresh innovations in those areas. So if this, like I said, if this is an area of interest to you, go to the video description, click on that link. It will take you to the place where you can purchase your Arduino kit. And if you're having any difficulties getting the Arduino kit, I've included my contact there. Get in contact with me and I could purchase it for you and then ship it directly to your home. Of course, there will be an extra cost onto it because of the shipping and so that kind of thing. That one will happen if you are not able to get it all by yourself. I would recommend you get it all by yourself, and then I do the teaching of the same. But just in case you can't be able to get it, then there is, of course, that other second option. So that's it. That is part of some of the things we'll be able to do this holiday. As you spend your holiday, do something, learn some coding. The next thing, of course, is we are going to have some scheduled online lessons in physics, and I'll be able to give you more information in a day or two, so that for those again who are interested, you could be able to register with me so that we can start learning some of the topics which I know, like for example in Form 1 you'll be expected to do some work in Form 2 work, but maybe you may not be having the course book. The course book has already been retracted by the school. So what happens is, because I've got a digital copy of that book, I'll be able to send it over to you, and plus other digital materials that I may be having in PDF form, of course, so that you can be able to compare our course book with other textbooks internationally. Because there are other textbooks, very good textbooks out there. You need to expose yourself to them so that you don't just think in terms of the course book which is given for our syllabus only. Try to expand your knowledge. Like I told you, you can't just rely on the information which you learn from school to survive in the world. You will need some of the information. You will need to educate yourself outside the classroom, outside the school. And this includes having other textbooks, other course books. They may be for different systems, but physics remains physics. Any science subject remains as a science subject. You may find more information, in which case you're going to supplement what you are lacking, or you may find more easier way of understanding a particular topic. And if maybe the textbook that I send you has got just basic information, you can discard it. But majority of the textbooks which I'll be sending you will be of, they are going to be very valuable to our system, because I've got an experience in that system as well as some other international systems. I've got an experience in those ones too. So I'll be able to select books which I know are of use to you. Now this one will only happen if you come in and you're taking lessons from me. Don't ask for these books and you are not in my class, because I'll be using those textbooks in my class to teach you. So that information will come in a day or two, because I already have your contact. I will send them to you via the email address which you will have provided, and of course ask you to register formally to be in that class. Now, since time is of essence, I will not only be teaching my own students. There will be other students from other schools. So it's important that when I give you that opportunity, you reply immediately, so that the system slots your time into my system, so that when I know it's time for this particular class, then you will not miss out. Otherwise, if you're shut out from the system, then you will have to wait until next term when we close again. That is when such an opportunity again will be opened. Otherwise, that is it. If this one is an area that you're interested in, just get in contact with me. If it's the Arduino you want, you know where to go. If it is registration for the class, again, you know exactly what to do. So I'm going to get in contact with you in 1 or 2 days. There will be a form for you to fill in. And of course, I will have other extra information besides that. Like, for example, the financial aspect of it, because the app that I'll be using, because I wanted all the features for that particular app, I had to go to the professional version of the app. And that means I have to meet certain financial obligations. Everything will be directed onto the person who initiates the lesson, that is the teacher. Otherwise, the student, there is nothing for you to pay over there. So that is why there will be a certain financial obligation that you'll have to meet if you have to be in my class. You will receive all this information in my next video. So be on the lookout for it, because it will have more information, including the form that you've got to fill to be in the class. See you in the next video.